Hi, this video is an introduction to confidence intervals. So today is the day we get to statistical inference. Okay, so here's an overview of what we're going to be looking at. We'll talk about polls and statistical inference, confidence levels and critical z-values, standard error and margin of error, and confidence intervals. Okay, so as a way of introduction, let's go to the real world and look at an actual poll. And we've been studying things like this. What we did with sampling distributions, you remember we've probably done something like this, where we took a survey, and what we did was we repeated random samples. So we took first a sample size of 3, and we averaged them. We figured out the proportion who said yes, and we did that for many, many samples, and we got a distribution. And we did it with a bigger sample size of 5. We got a distribution. All of this was to learn how random samples behave. So we learned about the central limit theorem, and we saw that if you take large samples, this is samples of 1,000. Let me move that up a little bit. Samples of 1,000, we saw that we had a normal curve, and we learned the formulas for the mean and the standard deviation. So we're going to be using all that today. So in this, further in the packet, there's a box, and we've been practicing this in the previous section. Our p hat, which is a sample proportion calculated from a sample, follows a normal distribution with a mean of p and a standard deviation of the square root of pq over n. And of course that's as long as these 4 conditions are met. Okay, so what's different now, the reason I wanted to review that is to make this transition. So in this section we knew our p, we knew our population proportion, so that we could understand what's the distribution of random samples. But in real life, we usually don't take surveys over and over and over again. We take one. And so now things are a little bit different. We're going to be taking one sample, and we're going to take that statistic and try to infer it back to the population. Okay. Now these polls may be done over and over again to see patterns throughout time, but as far as each point in time, they're doing the poll or the survey one time. Okay, so let's look at an example. I have a link here, and it's on my website, caraleemath.com. I'm going to go there right now. And let me scroll back up to the top. Okay, so this is Pew Research Center. And they take polls all the time. There's several of them. You may have heard of Gallup or 538. There's many, many polling organizations with websites. Oops, I'm not on the right page here. Okay, here we go. This is the original article. We're going to go to that page in just a minute. So this is Pew Research Center, and this was done in October 2018, talking about healthcare coverage. So you can find polls, all kinds of political polls, presidential approval ratings, things like that. I wanted to focus on healthcare for this topic. Okay, and we can see from this graph that they are actually doing this poll. They're repeating it over time. So you can see it goes all the way back to 2000. And they're repeating this poll. I'm not exactly sure, exactly how often, if it's once a month or a few times a year. We probably can get an idea from these points. It looks like maybe every 6 months or so. And then we can see the latest result is saying 60% of the people polled said that it's government's responsibility to provide healthcare. Healthcare is a basic right. So I want to study this poll a little bit more in terms of how did they get this number, how did they get their sample, what was their sample size, and another thing we need to know is what was their confidence level. Okay, so let me flip back to the packet for a minute. This is that same shot right there. And these are the things that we need to understand. These are the things that are important bits of information that we need to calculate confidence intervals. We need to know what their sample proportion was, their margin of error, their sample size, and their confidence level. Okay? So one thing we can say right away is their sample proportion is 0.60 because they found that 60%, let me make sure that's in focus. Yeah, they found that 60% of the people they surveyed at that time said yes. They said that the government should be responsible for healthcare. Okay, so we need to look for margin of error, sample size, and confidence level. So I'm going to go back to the article. And feel free to go here and look for these things yourself also. This is a great article. I encourage you to read it. They also did more than just this one poll, so they're describing more complex things. And I would just want to focus on this one poll in particular for today. So they, like you can see, they broke it down versus Democrats and Republicans. Here's another graph with all the different groups. They said, you know, leaning conservative, moderate liberal. Okay, here's what I want to get to is the methodology. So at the bottom of any poll, they should talk about their methodology so that you can understand how they got their numbers. Okay, so here we can get some more information. This says it's a national sample of 1,754 adults. And then they'll tell us a lot more about the sample too. So I'm going to write that down on my sample size. 1,754. It tells us how many were interviewed on a landline, a cell phone, including people who had who have a cell phone but no landline. So it says a combination of landline and cell phone random digit dial samples were used. Interviews were conducted in English and Spanish. Tells you more about how they selected which person, if it was a landline, because you don't know who's going to answer the phone. Here is another very important part. It says the combined landline and cell phone sample is weighted using an iterative technique that matches gender, age, education, race, Hispanic origin, and nativity, and region to parameters from the 2016 Census Bureau's American Community Survey. So they are really taking care to make sure that this is a representative sample in gender, age, education, race, Hispanic origin, nativity, and region. So that's great. They are also they're trying to match current patterns of telephone status. Some people have a landline only, some people have a cell phone only, some people have both landline and cell phone. So they even go on to say that this accounts for the fact that respondents with both landline and cell phones have a greater probability of being included in the sample. So they're adjusting for that. And household size is a factor. If you have 5 people and 5 cell phones, or 5 people and just 1 landline, that's very different, right? Okay, so that's all about the sampling methodology and how they got a representative sample of this 1,754 people. And then let's scroll down a little bit further. The other thing we need to know is the confidence level. So most surveys will use a 95% confidence level, and I'll show you all about what that means and how it influences our confidence interval. But this one is in fact saying they used a 95% level of confidence. And then the last thing we need is right here. It's the plus or minus part. Have you seen that on polls before? It's usually in the fine print down at the bottom. It says plus or minus 4, plus or minus 1, plus or minus 2.5, something like that. This is for, I just want to focus on the total sample, the whole group, which was the 1754. And, but you can see it varies. The margin of error varies depending on different factors. So for this total group sample, they're saying it's plus or minus 2.7 percentage points. Now that is to account for what we call sampling error. You know, if we take this random sample of people, they won't say the exact same thing as this random sample of people, or this random sample, this random sample, this random sample. So that's called sampling error. It's not really an error. It's more like, I would rather call it sampling variation, because the numbers will vary from sample to sample. And so that's why we need this plus or minus to indicate that. And I'll show you all the factors that go into that. This is called the margin of error. Okay, so I'm going to write down the confidence level is 95%, and the margin of error is plus or minus 2.7 percentage points. Okay, so let me go back to the notes. Here you can see what I wrote. So our sample proportion is 0.6. That's the decimal form of a percentage. So we're really talking about 60%. And so because this is in percentage, I actually would need to change this to match the decimal over here, plus or minus 0.027. So this is in decimal form. So these two really go together. Whereas if these two are both in percentage form. Here was our sample size, 1754, and our confidence level was 95% confidence. Okay, so from that, we can give our confidence interval. Now, it's really important to give an interval versus a point estimate. You can see I have the phrase point estimate here. Our point estimate is 60%. But if we tell people we did a poll and we got 60%, people tend to think that is the exact number when it's really not, because of the sampling variation. We know it's around 60%, and we know our margin of error is 2.7%. So what we're going to do is subtract that and then add it, and that gives us an interval to say that the true proportion of the population is somewhere between these two numbers. Okay, so let's do it. We usually use parentheses, and we put the smaller value and then the larger value. So I'm going to put in, I'll do it in the decimal form, 0.60 minus 0.027, and that's 0.573. And then we put a comma, and then we put the upper value. So now I'll put 0.60 plus 0.027. 62.627. We could also write it in percentage form. So we could write 57.3% to 62.7%. Either one of those would be fine. Probably if it was in an article on the website, it would be in percentage form. So really what we're saying is we are 95% confident that the true proportion of people who think that healthcare should be government's responsibility falls within 57.3% and 62.7%. So this gives us a range, and this is called our confidence interval. Okay, so that's an introduction to confidence intervals. And next I will be showing you all of the nuts and bolts. I'll show you the formula that we're going to use to calculate this, that they used, and all of the pieces and parts of the formula that we need. So let me just see if there's anything else I haven't said here. So now that we've studied the sampling distribution of a proportion, which is called p hat, we can look at inferential statistics. So we want to take a single sample and make an estimate of the population parameter, which we do not know. So that's a little bit of a summary there. Okay, I'll see you in the next video.